since the chapter is about refraction, let's start about the laws of refraction. Does anybody want to tell the laws of refraction?
The angle of incidence, the reflected ray, and the normal at the point of incidence lie at the same line. The ratio of the sine of the angle of incidence and the sine of the reflected ray is constant at the given pair.
Okay. It's also called as
Snell's law.
Alright. So can you give me a equation for it? Sin I by sin R is equals to.
It remains constant.
Good. Sit down. Okay. Since we spoke about refraction, let's not get confused with reflection. Okay. Somebody tell me laws of reflection.
The angle of incidence and the angle of reflection are equal. The angle of incidence, the normal and the angle of reflection all lie in the same plane.
Okay, good. Sit down. Alright. What is okay? Now we also learned about the effect of speed, frequency, and wavelength due to the refraction of light. Can somebody revise on that?
When a ray of light gets refracted from a rarer to a denser medium, the speed of light decreases while it gets refracted from a denser to a rarer medium, the speed of light increases. And the frequency does not change on refraction and depends on source of light.
Okay.
The wavelength changes on refraction, and the speed of light in a medium is related to the frequency and the wavelength.
Okay, do you know the formula? Wavelength is equals to. Did everybody understand this?
Yes, ma'am.
Okay, so now the light normally have to travel this way, but then it's bending because of the change in medium, because it's coming from rarer to denser to again rarer medium. That's why you can see 2 times the light is getting refracted here. Okay, alright. Now we'll get to the last question.
Angle of incidence, the wavelength used, the thickness of the block.
Okay, good. Sit down. Okay, what is it? Less? The speed of light is less.
It's more in air or vacuum, and it decreases as the density increases.
Okay, good. Sit down. Alright. Can somebody tell me the factors affecting the refractive index?
Nature of the condition and physical condition of such as temperature and wavelength of light.
The color or wavelength of light. It's nature of the medium. Okay, good. Alright. Remember the prism experiment that we did? Can anybody explain that? Ongoing.
So this is a glass block. Both the sides we have air. So first there is an incident ray which is coming and striking the glass block. So at this point we will draw a normal, say M dash. So what happens is that, as we know, it travels from a rarer medium to a denser medium. So the refracted ray will become closer to the normal. So the refracted ray comes closer to the normal. So this is the refracted ray, that's the angle of refraction, and this is the incident ray. Now after this, when it hits the end of the glass block, we have to again draw another normal, say N dash. So what happens here is that, as we know, it moves from a denser medium to a rarer medium, so it moves away from the normal. So this is again the angle of refraction, and this is again. So this is actually the initial action the light ray had to move. But it's not only that action because it's going from a rarer medium to a denser medium. So there's actually a difference between the initial part and the different so this is what is an acceleration.